Good morning, everyone, from sunny Southern California, and good morning on a GIS day. Today is the Worldwide National GIS Day, so hopefully you're taking advantage of that as well. My name is Mike King. I have the privilege of leading up the call-taking team at Esri, and we're really pleased with what we have today for our final webinar for the 911 industry, and I think you're going to find some interesting nuggets as we look at the county of Roanoke and the efforts that they have put into place as they've developed a regional 911 and next generation 911 system for the PSAPs there. I am joined today by my colleagues Brenda Martinez and Ray Umali. We also have remotely Britt Bromley, who manages our public safety partner program. Today we'll be actually hearing from one of our partners that we think a great deal of at GIS Inc., and also Chris Albert, who leads up our business development in this area. Let me just take a minute and introduce those who will be presenting to us today. And I would like to make note that Ray Umali will perhaps from time to time interrupt if there's a pressing question. You'll notice in your chat windows that you have the ability to ask questions. If it's something that we think is pertinent for the moment, we'll interrupt and ask that question. Otherwise, we may save those till the end of the webinar or follow up with you individually via email. I'd like to introduce David Ray, who's the GIS manager for Roanoke County, Virginia. David came to the city of Roanoke in 2012, or to the county of Roanoke, I'm sorry, Dave, and has been with them since. He has more than 26 years of IT and GIS expertise and is considered an expert in many areas, having served with Homeland Security, worked in organizations like DoD and the National Defense University, and others. We are really pleased to have Dave share with us what the county undertook, and they leaned upon one of their partners, GIS Inc., and we have Chris Blinn from GIS Inc., who is in their local government section. He's got more than a decade of experience working on complex solutions at the city, county, and state level, and has provided experience in the next gen 911 arena across the United States. So fellas, we're really excited that you were able to take time, and we're looking forward to the information that you're going to share with us. I'll let you run with it from here, although at the end I may jump on for a moment and just close out the webinar. And thanks again, everyone, for joining.
Thanks, Mike. Appreciate the nice introduction there. Again, good morning or good afternoon, depending on where you're located at. We're going to talk a little bit today about our regional Next Gen 911 PSAP project and tell our story and the experiences that we uncovered, or I guess we that took place during this project. So geographic information systems is vital to the success of Next Gen 911. It's a dynamic and spatially correct homogeneous Next Gen 911 data set was necessary for the entire Roanoke Valley area. And that's a little bit of a, for Virginia, and Virginia is a commonwealth. So with a commonwealth, it's a little bit different than, say, a regular state such as North Carolina, where actually in a commonwealth, each locality, the county and the city, maintain their own parcels, their own street center lines, their own address points. So creating that homogeneous Next Gen 911 data set was a little bit of a problem solver, right? We needed to think a little bit, think how we could leverage technology and think outside the box of how we could actually make that happen. So during the first part of this project, phase one occurred, which we didn't get full funding during phase one of the project. We got partial funding just because of where our project ranked among other projects that were submitted to the 911 Services Board for funding. So we had some partial funding there that allowed us to basically put together a script, a basic script that would actually take data, extract the data, transform it, and load it into a homogeneous database. So we were fortunate enough that the following year we applied and we got fully funded for this project, basically because GIS data was a top priority at the state level, because they knew that GIS data is so important for the success of Next Gen 911. So central to phase two, we injected business logic and we added intelligence to the consolidation and publication routines. The business logic focused on detecting and mitigating deviations between the source data from each locality, with an emphasis on boundary areas that required data stitching. So with more seamless integration, the data was more operational and capable of supporting increased functionality, such as the concept of cross-jurisdictional routing, which a lot of computer-aided dispatch softwares use that functionality. Additionally, the Roanoke Valley Next Gen 911 PSAP project advanced additional logging, analytics, reporting, and monitoring to the project. So what is what do we have now? We have the legacy 911 and we have Next Gen 911. And just some of the differences here are that the 911 system was originally built using analog technologies, and public safety answering points across the country needed to be upgraded to a digital or IP-based 911 system by 2021. So in Virginia, we need to, our goal, I think, for our area is 2021 right now. The success and reliability of 911 will be greatly improved with the implementation of Next Gen 911. It'll enhance the emergency number services to create faster, more resilient system that allows voice, photos, videos, text messages to flow seamlessly from the public to the 911 network. So Next Gen 911 will also improve the PSAP's ability to help manage call overload, natural disasters, transferring of 911 calls to another PSAP, and promote proper jurisdictional responses based on location tracking using your GIS. So the transition to Next Gen 911 will involve more than just new computer hardware and software. Implementing Next Gen 911 in states and counties nationwide will require the coordination of a variety of emergency communication, public safety, legislative, and government entities. So how do we get there? So fortunately, in Virginia, we have the PSAP grant program, a multi-million-dollar grant program administered by the Virginia 911 Services Board. And the purpose of this program is to financially assist Virginia's primary PSAPs with the purchase of equipment services that support the continuity and enhancement of wireless 911. So since Next Gen 911 is focusing on using GIS data and everything, that's how we secured the funding for this project. And funding builds capability, as we all know. So we leveraged the PSAP grant to build this capability, and now we're a little bit ahead of the curve in the Roanoke Valley, because now folks are trying to put their data together and create that homogeneous data set where we're finishing it up. So it feels pretty good to be a little bit further along than some other folks. So I spoke about this a little bit earlier. The problem was we had 3 localities. We got 3 different computer-aided dispatch software applications, which is 3 separate geodatabases that needed to be fused into one homogeneous data set. Well, now technology is available to make this happen. So, and we'll talk about that a little bit more today. I will say that the one thing that for this project to be successful, and it wouldn't be successful if we didn't do this, is that once we took and we created this homogeneous database, that we needed to ensure that that data from that ETL process could be digested by each of the CAD softwares used by Roanoke County, the city of Salem, and the city of Roanoke. And we know, and looking at the screen here, we see that we have 3 different types of CAD software that are used by the 3 different localities. So that was our goal, and the biggest goal that we had that we needed to make happen for this project. So after reviewing, and we looked at the VITA and the NINA standards for E911, we updated the scripts, and we noted some schema changes, and from the current process, we updated our standards, and then we took on the task of merging those data sets together to export that data out so it could be consumed by the CAD and everything. So if we move to our goals and objectives for this project, we wanted to basically create and maintain a real-time or a near real-time REST data access point. We wanted to merge each locality's data set together to create one enhanced data set for the Roanoke Valley area. We also wanted to construct a consolidated data representation that could support regional workflows, create that routable street network, and install server monitoring software. So basically, with all that's being said, our goals and objectives was we wanted to share that common data set, such as the road center lines, the address points, the emergency service zones, the PSAP boundaries, the municipal boundaries, the tax parcels. We wanted to actually create a collaboration so we could communicate and share that information. And then, like I said before, we wanted to integrate that data into each locality's computer-aided dispatch software. So looking here, this is a architectural diagram from phase 1, where the project was not fully funded in its first year. And during phase 1, we created the groundwork for phase 2, which I think was a blessing in disguise, really. If you look at this and you look over to the right-hand side, you see that the flow of the data viewers, the PSAP committee, and the 911 centers were feeding data into the system, but they were not receiving any output. So no value-added information at this point was helping users to make more informed and better decisions. So, but during phase 1, we defined that PSAP schema shared by the 3 different localities. We looked at what was compatible with next-gen 911 data standards. We incorporated that draft model, the conditional fields, and we loaded and transformed that data using an automated process. And then if we move on to phase 2, it's a little bit more complex. Phase 2 was intended to expand on the data set by adding intelligence and capability that help functional and operational adoption across the collaborative. So the concept established by the regional group, the Roanoke Valley PSAP users group, allowed each participating agency to contribute data and input to guide a consolidated process and results that not only conforms to NENA 911 standards, but also blends in our local data as well, our local requirements that each CAD would need. So whereas during the initial phase of the project centered on the infrastructure and processing foundation, phase 2 was aimed more at requisite business intelligence that makes the data set more conducted to supporting day-to-day processes within each PSAP, as well as expand on the sharing capabilities across the organizations. So if phase 2 architecture supports improvements to data consumption and sharing, each municipality needed to be upgraded to the ArcGIS Enterprise 10.6 environment. So we set up each environment and we configured each environment to push data to the software using portal-to-portal collaboration. So we added that business intelligence. We converted our Python script to 3.x from 2.7. We developed a data stitching process to remove topological issues between participating data sets. We improved the data validation process when merging the data sets together. We changed the topology checks mechanism to avoid any known issues from phase 1. And then we also included, which is very important, I might add, the emsac, ALI, and GIS analysis checks on the data to make sure it's in 98% compliance. So that was a big project that we've been working on for about a year, a little over a year now, that this project has been moving along. So a lot of work, but I think a lot of reward at the end of the day. So without further ado, I'm gonna introduce you to my partner, Chris Blinn, with GIS Inc. And Chris, take it over from here.
Thanks, David. I really appreciate it. So what I would like to do is step into some more of the technical process that went into both phase 1 and phase 2. The previous diagrams are great for understanding the architecture, but this is more of a high-level approach. So as David mentioned, the phase 1 initiatives really were about how are we going to get this data into one conglomerated data set. And as you all can understand, there are many challenges that we were faced with. Every layer had its own schema, its own set of field properties that differed from other municipalities. So it was a step-by-step process of looking at each individual field, individual feature class, and deriving the proper merging processes into our ETL script. We also had challenges coming from how we were accessing the data. So in phase 1, we were obtaining the data for the city of Roanoke and the city of Salem over FTP, whereas because we were building everything on an environment that was on the county system, we were able to tie into SDE. So we had different formats as well to deal with. This really turned into a very extensive Python script, one that, although was put together very nicely and gave us the results that we wanted, was quite extensive and took a lot of troubleshooting and debugging to get right. But within that Python script, we did apply the VITA standards for Next-Gen 911. So really what that meant was ensuring that the fields that support a Next-Gen 911 compliant data set were not only in the data, but populated correctly. As David goes to the next slide to show you where phase 2 then was a big push to change the technology. In that time that we were developing phase 1, the Esri technology changed and distributed collaboration was introduced. And so we started following how distributed collaboration could really improve our workflow. With distributed collaboration, we could set up a portal for each of the municipalities. And as you can see, the highlighted area, we had items then created from each municipality. These are data items. So these are the individual layers that these municipalities are managing. By creating data items and then sharing them into a collaborative group, we then had access to all of those items. And then, of course, as David mentioned, we upgraded to the 3.x platform of the ArcGIS Python API. That really opened the door for how we could access, manipulate, and use those data items. In addition to still applying the Next-Gen 911 standards, we introduced Data Reviewer. And Data Reviewer really allowed us to get a more in-depth look at the quality of the data we were dealing with. Data Reviewer was allowing for topological and attribute checks that we didn't have before. And so finally, once everything was put together, now that conglomerated data set was additional data items that we could then use to create web maps and applications. So really, when I say distributed collaboration, David, you can go to the next slide. When we were looking at distributed collaboration, there were many flavors, and we chose to go with portal to portal for multiple reasons. Mainly because the ability to share the items is a little bit simpler in this case. But there are different flavors of distributed collaboration. But the main thing to understand about distributed collaboration is that it establishes a trust between those portals. So when we were able to set that up, it's now opened up a door for technology to really take the place of the human needs for communication, which we all know can be a shortfall in any project. So by putting the technology in place, we were able to then automate that collaboration of not only the data, but the ideas and the project. And fortunately, because everything was built around the Python.3.x, now we have a repeatable process as well. So if we were to ever get another municipality to add to this, all we had to do was update a configuration that we have set up against that ETL process. And so we can continue to add municipalities onto this and grow the PSAP conglomerative. But with distributed collaboration, it's important to remember that those items are shared within a collaboration group. And that's what makes them accessible to create other products such as web apps and applications. So now I'll send it back over to David so he can talk a little bit more about what was used with portal-to-portal collaboration.
Thank you, Chris. We decided, like Chris was telling you, we decided to implement the distributed collaboration, which was a perfect fit for our project. Collaboration allowed us to connect and integrate our GIS across a network of participants. It enabled us to organize and share content between individuals, the PSAPs, and the communities, each locality. So collaboration was based on a foundation of trust and driven by our common goals for our projects and initiatives, and which was perfect for Next-Gen 911 project. So once we established that trusted collaboration, you're able to extend your GIS content to a network of participants, which in this case was County of Roanoke, City of Roanoke, and the City of Salem. So we share in that content becomes discoverable for each participant in the collaboration, which fosters communication, right? So that, you know, we're on 3 separate networks, 3 different localities. And so we have that collaboration piece, the technology piece, but that technology piece helps foster communication between each 3 of the localities, which I think was one of the big wins from this project, right? That it actually enhanced our communication using technology such as portal-to-portal collaboration. So how do we use that? We use that to improve our communication, like I was telling you, and drive and help drive the success of the entire project. So we created some additional reporting tools that using such things as the operational dashboards and everything, so we would know what are the known topology issues with our data and what we needed to correct, if there's bad dispatches reported by each municipality and what to correct, editing, what edits have been completed, and on the ETL process, the ability to communicate any known data issues using crowdsource reporting, and also the emsac alley and GIS dashboards, or i.e. report cards, were also some forms of this example of this collaboration. So I'm just going to go through and show a few things listed out here that we have. So, you know, first off of the project, in order to construct this data, we needed to create a PSAP boundary. And the PSAP boundary is specifically for the public safety answering point or access point. It's not a municipal boundary. It's a boundary that is used just for the next gen 911 and our data sets. And so what happens is this PSAP boundary, and you see our some of the guys call this on the team here call this the hammerhead arrow, which allows us to be able to allows the data to work in each of everyone's in each CAD. So each CAD has different business rules, different logic, and so forth. So we had to work together to create a solution to be able to fix the boundary to meet our business needs and objectives. So the PSAP boundary is more flexible than using that municipal boundary. Also using this, it clears up some confusion about who responds to an intersection here. So using this boundary, and allows CAD to work because of the buffer tolerances and so forth. So using the point you receive, sometimes you can receive 2 hits for an intersection. So basically coming up with solutions in the collaborative environment that are editing this boundary to be able to fix or solve your problems was a big win from this project and creating this this PSAP boundary. Now, what we also did early on in the project is we created this crowdsourcing geoform collector, and which is it's a configurable template or form based for data editing of a published feature service, right? So we took this crowdsourcing, the PSAP dispatch issue geoform, which allows dispatchers and managers to enter data through a form and not through a pop-up window on a map. And so, but this also enables, Geo enables the data and the workflows by lowering the barrier of entry for completing a simple task of, we've had an issue with dispatch validation of an address, and we can actually enter this information in and be able to give some feedback to GIS analysts, GIS managers, PSAP managers, and so forth. And so we can look at this, and we have a map that shows errors that have points or calls that have not been validated, and the total number is over here in the top left-hand corner. You got some bar charts and graphs going on. So basically, you can take this information and have this information readily available to you. And one thing I'll note, if you look at this, this actually is a PSAP manager's storybook. So with Esri, you can create a storybook. And with this storybook, it has each one of either the geoform or the dashboard, and you just click on the tab at the top to go to each one. So you're not digging through the information. So you can go to the story map, and it's your hub of information, so to speak. So the PSAP manager has a lot on her plate, and being able to have one location to go get all this information at a quick glance really is helpful. So we can take that, collect that information, and display it, and at a quick glance get some instant feedback on what's going on with your dispatch and your validation dashboard there. The emsac dashboard is a view of the geographic information that helps monitor events or activities. So the dashboards are designed to display a multiple visualizations that work together on a single screen, right? So they offer a comprehensive and engaging view of your data and everything. So what we're looking at here is the Master Street Address Guide, or the emsac. And so we're looking at this, and we compare that data, and it's checked against the road centerline data using a series of imports and joins, and the different type of data elements that we're working on. And we haven't, this is that we're working on the complete here are some of the data elements that we will have, and we'll be able to look at this, and it's dynamic, it's happening real time. That we will have would be the total number of emsac records, the emsac street high and low numbers, the road center line to emsac, are they identical? The road center line to emsac matched for the segment locations. The RCL emsac not matched for segment locations. The RCL to match for low and high addresses, and the RCL to emsac match, not match for missing roads and address ranges. So we have all these different data elements that we can look at and see if we have that 98% compliance for our standards. So, you know, we're being proactive instead of reactive. So that's what this emsac dashboard and being able to publish this information out, so that me as a GIS manager or the PSAP manager could actually take a look at this and see how we're performing, how do we look at this day and time with our information. So the next one here is more of not using the emsac, but just pertaining to our GIS data. And some of those same things that we're looking at for the road center lines with the left and rights and the values, and doing a bunch of different data checks on not only the data, but the odd even parity of that data, and the invalid geometry, duplicate geometry, multiple part features, and so forth. So doing some sophisticated analysis and providing that information back in real time, very helpful, and shows the power of what's behind this project. And also, not only does the GIS Analytics dashboard use the road center lines and do analysis on that, but it also includes the address points, right? So we're also using address points to do some analysis on and some checks and balances there. The last alley dashboard that we have, which is the automatic location information database that's submitted by the telephone service provider, and so forth. So we use that alley database, and we use our local RCL and address point data sets, and we convert those into the ArcGIS locator files, and we perform some analysis on that using the street name match tolerance and using the alley database to geocode it against those locator files, and to see what we have. Do we have matched addresses for in the city? Do we have any unmatched? How much and what are they? So being able to have this information real time is quite powerful, and everything. So another example that we did is using insights. So we've collected all this data, and we've invested so much into it. Insights analysis is, if you're not familiar with it, it's quite powerful. It's web-based data analytics, and it uses location intelligence to help answer questions that you may not have known to ask before. So to be able to do this and to use this information, and the main thing I can drive home is that I think, yes, it is powerful analysis, and it's made simple, but the thing is that my take-home message is that you can do it very quickly. So the data is there, and using insights to be able to look at a heat map for your calls for service from our PSAP and you can do that by day, by month, by week, or by year, and so forth, or by incident type. You can put all that information together and have it available to you quickly, so that you can look at, well, what day is my highest number of calls? What time of day is my highest number of calls? Where are they in a particular location? And so Insights allows you to do that, and it is powerful, but the biggest thing I take home from it, because I've been doing this stuff for 26 years, is how quick it is. It's so quick and everything, that you can create a card and do this analysis and then copy the card and do a heat map, or take the same data and do a bar graph on it and just copy the card. So, you can just do it quickly, and it's right there at your fingertips. And the next slide is just another example of using the Insights dashboard here, of looking at from analysis and so forth. So just a lot of different capability that you can have here to use for analysis. And this is just an added benefit of portal-to-portal collaboration. So one piece here that we really wanted to be proactive on is that when the information comes into your CAD and you have, for example, you're seeing here a table that is populated, and they are dispatch issues that we're having, and that call didn't validate. And why did it not validate? So what we're doing now is we're creating a script that will actually be proactive. Well, we've already created a script, but basically trigger that script to run when this table was populated with a new dispatch issue, so that we're looking at this information. And so when we're using GeoEvent server, it's going against this REST service that has the dispatch issues in the table, and we're analyzing those services with scripts and business intelligence, and then we're going to send people that need to know, managers and so forth, event notifications of this is what happened, this is why it happened, and this is what you need to do to be able to fix it. So Chris, I'm going to hand it back over to you so you can do the technical talk on how we're leveraging GeoEvent.
Sounds good, David. For those that aren't aware of GeoEvent Server and what that software really does, is you can really think of GeoEvent as a listener software. And that software is listening for different data feeds that are coming in. And those data feed formats can be in many different varieties. In this case, it's a feature service. So when that feature service has something happen, say an update or add a new feature, GeoEvent's catching that event, and then it's going to do something for us. So what we'd like to do for that dispatch data is, when a new address is being submitted through that geoform, we want to then pull that information, geomap it over into a schema that we've created, and then send that data to a script. And that script's going to try and geocode that address that for some reason doesn't really work well with the CAD systems. Once we get some geocode results, or at least some data against those geocodes, we can then do some real quick summary data. Now, all that sounds like a pretty straightforward analysis that someone could run at their own machine. But by enabling it with Python and using GeoEvent to kick off that script, we're automating that process, which is streamlining the ability for these CAD dispatches to correct their data faster, which in the end, in regards to public safety, could end up saving lives. That's very important. So as we can introduce more and more technology to automate these processes and to correct the quality of the data, we're going to start generating, or we're going to start seeing better results from those public safety offices. So once the data is packaged and delivered from the script, we can send that email notification out to the correct personnel to correct the data, and then give them even some guidance on what needs changed in the data, so that we don't know, or I'm sorry, so that we no longer see a bad geocode result whenever that address is submitted. Back to you, David.
Thanks, Chris. So, you know, we spent all this time talking about data, and so forth. But at the end of the day, we also have our next gen 911 PSAP viewer, so that it shows our different law districts, our fire districts, and it has underlying tax parcel and address point information, has our streets base map and so forth. And we'd be able to determine if someone lives in this area, what is their fire district, what is their law district, the locality they live in, and so forth. And you can easily use this with our quick search, and you can search by tax parcel ID, owner name, or street address, and visually check that out with all three localities. So before this project could start, we could only use our data, Roanoke County's data, of looking at this quick search. But at the end of this project, we're now able to look at this, and no matter if you live in the city of Salem or the city of Roanoke or county of Roanoke, you could search on your address to be able to pull up your service areas for 911. So we're all looking at the same maps. We're all singing from the same sheet of music, so to speak. So what are our lessons learned? You know, our biggest take-home lesson is that, you know, using technology and portal-to-portal collaboration, it enhances our communication with other localities, because that's essential for Next Gen 911 to be successful. So now technology allows us to communicate and collaborate effectively, even if we are on different networks and we're on another side of the county from each other. But we can now leverage technology to foster that communication and collaboration. So our data editing standards, so we knew that we needed better data editing standards for successful CAD integration, and we did that, right? So we met together, discussed things, and communicated with each other to find out that, hey, we did need to know how we're all doing this data and what the right hand and left hand are doing. So preparation for Next Gen 911 takes time and teamwork. And the bonus of this is that once you've leveraged you can leverage the Next Gen 911 platform across the enterprise. So that now that you've done this and you have portal-to-portal collaboration for the PSAP project, you could also have a portal-to-portal collaboration for your different police departments. For example, looking at opioid overdoses and how to combat that problem, for example. So you can leverage that across the board on many different levels and everything. And everybody knows, you could just think of, you could take this same workflow, this same template, and apply it in different departments. So our goals and objectives. One, we wanted to share Next Gen 911 compliant common data set and schema that included road center lines, address points, the emergency service zones, including law districts and fire districts, created our PSAP boundaries, had our county municipal boundaries, and we agreed on those, our tax parcel polygons. We created our collaboration, and then we integrated the data into each locality's computer-aided dispatch. So, and this data is created and maintained in a near real-time REST data access point, and that now can support Next Gen 911. So without further ado, I guess we'll open it up for questions. I'd like to first just thank Esri for letting us do this, and thanks to GIS Inc. and Chris Blinn for all the help and support during this project. and there's a lot of other folks that really helped us out as well. But for right now, we'll open it up to questions.
Okay, thank you, David and Chris. First question to the both of you: which is the CAD system implemented along with ArcGIS? So I guess they're asking which CAD system you're using to implement that workflow.
Okay, so for Roanoke County, we are using New World Systems Enterprise CAD is what we're using, and we took and created our own ETL script to take the data out of the PSAP GIS database and transform it and load it into our New World Systems Enterprise CAD database.
Okay, and another question we have is, how did you deal with common place names, limited access roadways like freeway segments? Are these CAD vendors consuming this as the geofile source and converting it into a native format, or are they using it for real-time address validation?
Well, I would say we're using it for real-time address validation. So when we look at address validation, we're using first source as address points, and then if the address point it doesn't validate, then the backup would be the road center lines.
I would just add on to that, a part of our process, because there are 3 different CAD systems, the inputs to those are different. What we have, in addition to creating the conglomerated data set, is also then the Python processes to format that data so that it can be consumed by those CAD systems. For instance, the county system can actually consume the REST endpoint directly. So there was no additional work that needs to be done to convert that. But one of the city's CAD systems only works off shapefiles. So we have an additional part to our script to actually output shapefile items that are then formatted correctly for that CAD system.
Okay. Another question is the street centerline usable with Network Analyst?
Yes, it is after phase 2.
Okay. Here's a process question that I think David and Chris could speak to. Can you talk a little bit about the person hours needed to get where you are? How big of a team was needed for the creation and now the maintenance of the data, including errors?
I think I can talk to my team in particular for Roanoke County, including myself, is 5 people. But it's not like it takes 5 people that have been working on this project and so forth full time. Different people, different skills, different expertise are needed at different times. But I will say that this has been my main project to manage and so forth for the past year, and it does take. I couldn't tell you the number of hours, but total I could give you a guesstimate. I mean, I could run back and when I close the project out, say, hey, we spent 1,000 hours, but I'm probably guessing that probably for my whole team and so forth over the period of a little over a year now of how much time we spent on this project is probably approaching, I'm thinking 800 hours.
All right. Another question we have is, how difficult was it to get leadership support from all 3 organizations?
I think I can talk to Roanoke County and getting the leadership support for the project. I think the whole Roanoke Valley area is really big on collaboration with one another. I think the support from the top down is very important. We even got support from the Roanoke County Board of Supervisors, and so forth for this project. So I think from the top down, it wasn't that hard, because whether you like it or not, Next Gen 911 is coming, and the system, the old analog system, is going away. So you don't have a choice. You have to do this. But I think Roanoke Valley has always worked well together in fostering that collaboration.
Mm-hmm. And another question was, why did Roanoke County decide to use Esri technology as opposed to a third-party software or solution?
Well, ESRI is the common denominator. Each locality, I know the city of Roanoke and the county of Roanoke have an enterprise license agreement with ESRI. And I think city of Salem, they may have this an ELA, but they're also that's their primary source of software as well for their GIS is ESRI. So we all had that software common platform, and we were already invested there. And in my opinion, the enterprise license agreement for ESRI is the best bang for the dollar anywhere of what you get and what is made available to you. You have a lot of capability using the ArcGIS platform, and it was that was a no-brainer.
All right, and I think that concludes most of our questions. For those of you who did not get your questions answered, we will make sure to follow up with you on that following the webinar. David, if you could move on to that next slide.
Thanks a lot, Ray. And David and Chris, thank you so much for what you've been able to provide today in background and examples of where you've come to date. It's really exciting. I think I actually ended up getting the most excited when I started seeing your dashboards that you've created to track and manage address changes and updates and other kinds of things. And I don't know if any of that information, if we can get some screenshots or something, will of course make the recording available for anyone who wants to download and watch through. But you just did an excellent job. Thank you so much for taking time. And you gave me a beautiful segue when you talked about the Esri licensing. So for those that are on the call, just know that Esri has created some special pricing for enterprise licensing and for individual licensing for public safety. You can see a little bit of that on the screen. Those prices are even adjusting as we speak, and we're doing our best to try to take into account things like shift work and the number of telecommunicators that might be sitting in a PSAP and those who might need to do more heavy lifting than others. And so please reach out to your Esri rep. If you don't know who that is, respond, and we'll certainly help them connect with you so that you can explore that for your individual agency. I failed to mention Sean Gorman, who works here at Esri and helps manage our relationship with our partners and customers. And thanks to Sean for helping us get the Roanoke team on for this webinar. Closing, I'd just like to say watch for us in 2019. We're still going through the process of what 2019 will look like from the call-taking industry, but we will be at many of the events that you attend, NINA and APCO and IACP and many, many others. So please look for booths there and look for our upcoming webinars in 2019. We're going to do approximately one per quarter and hopefully bring some content and value to you at that point. So thank you again for taking time to be with us, and we hope you have a great day. And thanks again to the Roanoke team.